Welcome back. This is Arup Basu from ClusterMicro. So this slide covers two topics. The first is encapsulation. It is one of the four pillars of object-oriented programming and a core principle that the OCP exam tests both conceptually and through code. Okay. The second is var. So it's a Java 10 features for local variable type inference that the exam tests through specific rules about where it can and cannot be used. Okay. So let me start with encapsulation. So encapsulation is about controlling access to the internal state of an object. The idea is very simple. An object's data should not be directly accessible from outside the object. Okay. Instead, the object exposes a controlled interface, that is methods, through which the outside world can interact with the data. The object decides what is valid and what is not. Okay. The practical benefit is data integrity. If you give direct access to a field, any code anywhere in the application can set it to any value, so including invalid values. But if you force all access through methods, the methods can validate the input and reject anything that would put the object in an inconsistent state. Okay, so that is the difference. So let me show you exactly why this matters with the two account examples here. So we have public class BadAccount, public double balance. Okay. This class has one field, balance, and it is declared public. Public means any code anywhere can access and modify it directly without going through any method. Okay. Look at the commented line, account.balance is equal to negative 1 million. Okay. So this is perfectly legal Java. So you can set a bank account balance to negative 1 million directly. No validation, no check, no error. Okay. The field is public, so you can write whatever you want into it. Okay. So now think about what this means for a real banking application. And the developer writes account.balance is equal to negative 1 million and your account now has a debt of 1 million. Or they write account.balance is equal to double.max underscore value and your balance is now the largest possible double value. Or they accidentally write account.balance is equal to account.balance minus amount when they meant plus equals, okay, and the balance goes negative. So there's no difference. The bad account class has no ability to protect its own state. Anyone with a reference to the object can do anything to it, okay. So this is the problem that encapsulation solves, okay. Now comes the encapsulated class. So public class account, private double balance and private string owner, okay. So here if you see both the fields are now private. Private means they only can be accessed from within the account class itself. No code outside the class in other classes, other packages anywhere can read or write these fields directly, okay. The fields are now hidden. This is what the word encapsulation literally means, to put something in a capsule to wrap it and protect it from outside. But if the fields are private, how does the outside world interact with the account? So they interact through the control public methods, the interface the class deliberately exposes, okay? So we have getter here, public double get balance. So this is a getter method, also called an accessor. It provides read-only access to the balance field. The outside world can ask what the balance is and this method returns the value. But the outside world cannot modify the balance through this method. It is read-only, okay? So by providing a getter but no setter for balance, the account class is saying you can see the balance but you cannot set it directly. To change the balance, you must go through the deposit or withdrawal methods that enforce these rules, okay? So the naming convention for getters is so get followed by capitalized field name. Okay. So for balance, it becomes get balance B capital. Owner, it will be get owner O capital. Okay. For Boolean fields, however, the convention is instead of get, it will be is active, is valid, like that. So a OCP exam, it tests all these naming conventions also. Okay. Then we have the deposit method. Okay. So we have the deposit method and that is with validation. So public void deposit double amount, if amount greater than 0 then balance plus equal to amount, okay. So this is where encapsulation pays off. This method is the only way to increase the balance and it has a guard if amount is greater than 0. If someone tries to deposit a negative amount, perhaps as a mistake, perhaps maliciously, the condition amount greater than 0 will be false, okay. The body does not execute, it will not execute. So balance is unchanged. The invalid operation is silently rejected, okay. So if you compare this to BadAccount class where you could set account.balance equal to negative 1 million with no resistance at all, so you'll see that this is so much better. With account, the worst someone from outside class can do is call deposit negative 500. This method will run, check amount is greater than 0, find it false and does nothing, okay? The account is protected. So this is the fundamental power of encapsulation. The object controls its own state. The external code cannot bypass the validation because external code cannot touch the field directly. The only path to modifying balance is through methods that the account class controls, okay? In a real account class, you would also have a withdraw method with its own validation. So it will check that the withdrawal method does not exceed the balance, for example. Okay. Same principle, the method enforces the business rules. Then we have getter and setter for owner. So public string getOwner, public void setOwner. So here we have both a getter and setter for the owner field, making it a readable and writable from outside. Okay. So getOwner returns the current value of owner, read access, and setOwner, string owner, sets the owner field to a provided value. Notice the this.owner in owner is inside. The parameter and field have the same name, owner. This.owner refers to the instance field and owner alone refers to the parameter. Okay. So without this, both references would result to the parameter and the field would never be set. And now in this example, the setter has no validation. It accepts any string including null. Okay. In a real application, you might add validation, reject null, reject empty strings, enforce a maximum length, etc., etc. The point is that you have the option to add validation later without changing the interface. Okay. So external code still calls setOwner John. You can add if owner equals null, throw new illegal argument exception, etc. inside the setter, and the external code does not change at all. Okay. So this is another benefit of encapsulation. You can change the internal implementation at any time without affecting the callers. Okay. Now we shall discuss var, that is local. So var is local variable type inference. Okay. So var list, we have var list equal to new ArrayList string. Then we have var I equal to 42. So we have var list equal to new ArrayList string. Instead of writing ArrayList string list equal to new ArrayList string, you write var list new ArrayList string. The compiler looks at the right hand side, the new ArrayList string, and infers that list must be of type ArrayList string. Okay. So the type information is not lost. The compiler knows it. So you just did not have to write it twice. Okay. And then we put var is equal to var I equal to 42. Okay. The literal 42 is an int. The compiler infers that I is of type int. So equivalent to int I equal to 42. Okay. So var is purely a compile time convenience. At runtime, there is no difference between var I equal to 42 and int I equal to 42. The byte code is identical. The type is fully known and enforced by the compiler. Okay, var is not a dynamic typing. It's not like JavaScript's var. So it's statically typed. The compiler knows the type, and you just did not have to spell it out. Okay. So there are a few rules that you need to understand and remember. So rule 1 is var must be initialized at declaration. Okay. So var x semicolon, it will lead to compiler error. But if you put var x is equal to 42, it will be okay. The compiler needs the right hand side to infer the type. Okay. So without an initializer, there is nothing to infer from. Okay. And rule 2 is var cannot be initialized to null. Okay, you cannot put var obj is equal to null. It will lead to compiler. So null is not a type, right? The compiler cannot determine from null alone what type obj should be. Okay, so you must use an explicit type. String obj is equal to null. That will work because the type is declared. Okay. And rule 3 is var can only be used for local variables. Okay. So in a class, if you put var name is equal to John, it will lead to compile error. Var cannot be a field, cannot be an instance variable. But if you put var name equal to John in a method, it's fine because it's a local variable. So var is only valid for local variables declared inside a method, constructor, or initializer block. Okay, so it cannot be used for instance fields, static fields, method parameters, or return types. Okay. And then var is a reserved type name, not a keyword. This is the subtle one that the exam loves. Okay, var is not a keyword in Java. It is a reserved type name. That means if you put int var equal to 5, it's okay. Var can be used as a variable name. Okay. So it will compile. Var as a variable name is legal because var is not a keyword. But if you put var equal to 5, that will be a compiler error. Okay, var cannot be used as its own type. Okay. So this does not compile because you are trying to use var as both the type and the name, okay? And the compiler cannot infer the type from 5 when the declared type is the reserved name var, okay? And there is a rule 5 also here. So var can be used in for each loops, okay? So if you have var list is equal to new array list, then string, then list dot add hello, then for var item colon list system dot print out dot println item. So item will be inferred as string, okay? So item is inferred as string because list is an array list string. So the for each variable can use var, okay? So thanks for your time. Hope we are able to clarify both encapsulation and var here. So see you in the next video.